Okay, as I promised, so I'm going to work out the one final exam for you. So here, let me choose this one. So this is a close one, 2022 fall. Let's go to final exam. It's online version. Let's find its printing version. Okay, I don't know why it shows 21 anyway. So let's see how many questions in total. So 18 questions in total, but I'm not quite sure if your exam will be exactly the same amount of number. But it's about in this range. Okay. So make sure you give your name, very important. And also make sure you work out your steps, right? Because each step counts, especially some crucial steps. Do not skip any. If you write on your scratch paper, you have to copy down to your exam paper. Okay, make sure on your exam paper you have steps. Let's see the first question. First question is determine an algebraic expression of a function for this graph. So we know a function has at least five presentations. Just like a person, just like me, right? I'm home, I'm a mom at home, but I'm teaching in school, stuff like that. So a function has five kinds of representations. So graph is one of them, and the algebraic expression is another of them. What do we mean by algebraic expression? If you see f of x equals to x cubed minus x, representing with the numbers and the variables, that's called algebraic expression. So for this one, we know this is the even degree of polynomial, right? Because it's one piece of string. The domain is every real number. And the two ends, the end behavior goes down to negative infinity. So we know the leading coefficient is negative. So I have two pieces of information already. So first is the degree of even polynomial. And for how many, what's the degree? Well, let's count. If we goes once, we goes twice, we goes three times. So it's a degree 4 polynomial. Degree 4 polynomial, and with leading coefficient to be negative. We see 0, 0, the origin is on the graph. The origin is on the graph, and the origin 0 also is a root. So we have x minus -2 as a factor, or x plus 2, then x as a factor, and then x minus 1 with degree 2, because it touches x-axis, then turn around. So then we could use this 0, 0 to work out our leading coefficient, which is a -1, negative. All right, that's it. Negative x minus 1 squared, x plus 2. Okay, see polynomial degree 4. So that's number one. Let's see number two. Number two is a sine function, right? This gives us amplitude. And this is a b. In the standard form, we call -2a, then sine, then this we call b. So b help us to figure out the period. Sine is a periodic function. So this b divided by 2 pi give us the period, one period of sine function. Then this -2 is vertical shift. Vertical shift. So 1/3 divided by 2 pi, what do we get? We get 1/6 pi. Right. So no, 2 pi divided by b. So 2 pi divided, so b is 1/3. 2 pi divided by 1/3 is the same as 2 pi multiplied by 3, which is 6 pi. So by 6 pi is here. By 6 pi, we will finish one period. Graphs. I don't want to graph. Sorry, I cannot stop this. And -2, so sine, so 0, 0 is on the sine. So how do we graph? We use 5 points. Let me see, how do I do? I'll clear all. I can clear here. So first, we know 6 pi. Okay, maybe make a point here. 6 pi. Then we use 5 points. So 6 pi divided by 2, we have 3 pi. And the 0, 0 is 0, 0 is on the graph also. And then 2 more points, 1 in between this one, another one is here. So we use these 5 points to graph. So -2 give us the first is reflection over x-axis. So sine starting from here, right? Originally, if we were positive, but now it's negative. So we know sine starts from here. So starts from, so -2. Okay, hold on. So this is 0, 0, starts from here. How do I graph? So this is my point. My point. Okay, yeah. It goes here. It goes down below -2, but then goes, or maybe I should make a point here. Then goes up to, so how do I change the graph? Sorry, I'm not used to this, to do this. So basically you see the graph should go from 0, 0 to this -2, pi over 2, -2, then goes to, not this point, this point. Hold on a second. So let me clear off again. So let me go to 6 pi, 1 point, 3 pi, 3 pi over 2, 9 pi over 2. Okay, we use these 5 points. So we'll get another 2 points. So 0, 0 is on the graph. Now, this is on the graph. Then this one is on the graph. Sorry, I don't know how to graph this, but I'm going to give you a right graph. Then we have to shift down everything 2 units because of this vertical shift. So basically we shift down the 0, 0 to 0, -2, this point to here, so on and so forth. So we move the 5 points 2 units down. Then we graph the sine curve like this. If you can see it, then here, then back here. All right. I think I have answer here. Right. Yeah. Okay. It goes from, so 0, 0 now moved to 0, -2 because of the vertical shifting. And Okay, that's question 2. Question 3. We want to graph this quadratic function. Quadratic function, we want to figure out, well, let me get my pencil. We want to figure out our vertex. Right? The typing, oh, it's here. So we need to figure out our vertex. What is our vertex? Because we're given standard form. So in the standard form, we have A, B, C. So A is 2, B is 8, C is 6. So vertex x value equals -b over 2a. Right? Then that's just a function value. So that's our vertex. So let's write down A, B, C here. So A is the number before x squared, which is 2. B is the number before x, which is 8. C is a constant, which is 6. So we plug in here, we get x equals to negative, or B is 8, divided by 2 times 2, which is -a divided by 4, which gives us -2. Then we evaluate f of -2. F of -2. Going back to the function, there's 2 times -2 squared plus a times -2 plus 6. Just calculate, right? -2 squared is positive 4. Positive 4 times 2, that's 8. Then 8 times -2, that's -16. then plus 6. So what do we get? Maybe this longer. Oh, okay. So negative 16 plus 6 is negative 10. A minus 10 is negative 2. So we get a negative 2, negative 2. So that's our, how do I graph? Oh, let me change it to be my pencil. So negative 2, negative 2. So we're finding negative 2, negative 2 is here. Negative 2, negative 2. So this is our vertex. Right? Our line of symmetry goes through the vertex. So this is our line of symmetry, which is x equals to negative 2. Then we need 2 more points. So this is our vertex. Our graph goes, the a equals to 2 is positive. So our graph is an upward parabola. Upward parabola. You make sure you draw like a curvy shape, smooth shape. So what do we do? Let's evaluate f of 0, right? Let's evaluate f of 0. X equals 0, this is gone, this is gone. So I have 0, 6. So 0, 6 here. And then by the symmetry, we have a point here. All right, so we can graph. My graph will probably look horrible, but so make sure you give a arrow to indicate the graph keeps going. Okay. My graph, I'm sure you can draw better. Okay, I'm drawing on my trackpad. It's very difficult for my fingers. So that's it. That's the graph of a quadratic function. All right. So A, the leading coefficient, tells you the graph goes up or down. And how do you graph? Given your standard form, you find a vertex. Okay, the vertex, the x value is negative b over 2a. Then you evaluate at the function, for the function at this point. Then you get one more point. You just find some easy x values. Right here, I use x equals 0. So get a 0, 6 point. Then by the line of symmetry, I get another point on the left. Then I can graph. And that's it. All right. If you want to find the roots, the x-intercept, that would be perfect. All right. Finding how do you find the x-intercept? You set this one equal to 0. If you set this one equal to 0, let me finish this. So I have 2x squared plus ax plus 6 equals to 0. Do you see this can be simplified? The 3 terms can be divided by, so 2 is a common factor of those 3 terms. So I divide by 2 for every term. I get x squared plus 4x plus 3 equals to 0. Oh, this can be factored. Factor as x plus 1 times x plus 3 equals to 0. So I get the 2 values, negative 1 and negative 3. All right, so that gives me 2 points. That give me negative 1, 0, and negative 3, 0. So I get those 2 x-intercepts. So I use my pencil. So negative 1, oh, you see? So negative 1, so my graph is not too far from it. So negative 1 here, and negative 3 here, all right? Okay, that's question 3. I need to erase everything. Where do I erase? Oh, erase it here now. Yeah, clear everything, yes. Okay, now I cannot move this one up. Okay. Let's see number 4. Number 4 is a rational function. Right? So we see, but we see 3 pieces of string. We see this one on the left and this one on the right. And then we see one in the middle. So that tells us this. Let me show you the answer first. You see, we have a square. right? We have x minus 2 in the numerator, x plus 1, x minus 3 squared. Let's see where do we find these pieces of information. So first, I see two vertical asymptotes. Right? That tells me in the denominator, I have x plus 1, and I have x minus 3. I have x plus 1, x minus 3. Why x minus 3 squared? You see these two pieces, one on the left, one on the right. Remember the reference graph. The reference graph is one piece in the first quadrant and one piece in the third quadrant. But if we have a square term, that changes that. Okay, so how do we figure out this leading coefficient 9? That's by this y-intercept. You see 0, -2 is our y-intercept. Right? And when do we get the function value to be 0? When the numerator is 0. Where do we get that piece of information? We see we have a root here. We have 2. 2 is the root of this function. Is the x-intercept of this function. So that tells us that's x minus 2 in the numerator. So x minus 1, x plus 1, x minus -1, which is x plus 1, x minus 3. And by this one, -2, so you plug in 0 into it, then to find the leading coefficient of 9. Because the function value equals to -2. Right? You use this point to find the leading coefficient. Let's see number 5. 5, I have log function. For log function, the domain is important for us. Right? Domain is important for us. We see if we remember the log function, reference graph, right? We have this common point, the reference graph. So it's important to remember the reference graph for some difficult functions. It keeps going down, getting closer to y-axis, but we'll never touch y-axis. So that's our reference graph of log any base of x. Right? So remember this reference graph in your head. But now for this function, I need to erase this. Okay. For this function, what is the domain? The domain is this value has to be greater than 0, which means x has to be greater than -2. Right? We move positive 2 to the other side. X has to be greater than -2. So we are going to find our vertical asymptotes of x equals to -2. So we draw a vertical line here. So this is the horizontal shift of the graph. So the y-axis was the vertical asymptotes for the reference graph. But now for us, it shifted 2 units to the left. Then also we have this vertical shift, right? Vertical shift down 2 units. So that means we can draw this, so that means x-axis being lowered down 2 units. Then we can plug in some easy values, right? Let's see x equals -1. If x equals -1, that's here. -1 plus 2. -1 plus 2, that's 1. Log of any base of 1 equals 0. 0 plus 2 is 2. So we get a 1 point. Oh, you know what? I made a mistake. It's not lower down. It's going up 2 units because this is plus. It's plus. It's not going down 2 units. It's going up 2 units. Sorry, I don't know why I made such dumb mistake. So draw our vertical asymptotes first, which shows the domain, which is saying the graph only survives on the right-hand side of this vertical asymptotes. Then move up 2 units. So think our x-axis being pushed up 2 units, because this helps us to graph. Now plug in some easy values for x. Well, if x equals 0, we get 0, 1, because log base 2 of 2, when the base and the value are the same, we get 1. So let's graph that point. So we have 0, 1. 0 is here, 1 is here. So get this point. Get this point. If x is a -1, we get 0. So get this point on x-axis. Right? Then what about x equals 2? X equals 2. 2 plus 2 is 4. 4 is 2 squared. So we get a 2. So we get this point. Now we can graph, right? With these 3 beautiful points, we can graph. So the graph just keeps going down along x equals -2 is our vertical asymptotes and keeps going up smoothly like this. All right, so that's the graph of this. That's 5. Now let's go to 6. Oh, let me show you the graph. See the graph like this. Make sure you tell yourself x equals -2. It's better to draw the vertical asymptotes. Okay, at x equals -2, that's your vertical asymptotes. Let's see question 6. We want to solve these trig equations. Let me grab my pen. So we have 2 cosine square gamma. Gamma is just an angle, okay? It doesn't matter, just a variable. If you don't like a cosine, you can use k or t to substitute, right, to convince yourself. So this one, if you have good eye, if you're good with the factoring, you see this can be factored as 2 cosine gamma. I don't have gamma, I'm going to use r, okay? -1 times cosine gamma -3 equals to 0. Right? You have 1 cosine gamma plus -1 cosine gamma plus -6 cosine gamma, so you get -7 cosine gamma. Right, you see, if you multiply those two, that gives you your first term, 2 cosine square gamma. If you multiply -1 with -3, that gives you +3. If you when you multiply those two, you get negative cosine gamma. When you multiply those two, you get a -6 cosine gamma. Add together, that gives you the middle term. That's how you factor this. Okay, once you have factor equal to 0, you use zero property. Zero property is seen when the product of certain things equals 0, that means each factor can be 0. So 2 cosine gamma -1 can be 0, and the cosine gamma -3 can be 0. Well, let's see the first one. So move -1 to the other side, we have 2 cosine gamma equals to 1. And the other one we have cosine gamma equals to 3. Well, what's wrong with cosine gamma equals 3? Cosine value at least 1 or -1. It will never be 3. So we can ignore this answer because this will never be true. So we only have one solution. That's 2 times cosine gamma equals 1, which means cosine gamma equals the half. Well, remember all students take calculus. So in the fourth quadrant, in 4 quadrants, we have 4 quadrants. Cosine being positive in the first quadrant and in the 4th quadrant. So I have 2 solutions. That means gamma equals to, so gamma equals to 2 values. In the first quadrant, when it's a half, it's a pi over 3. Over 3. Or 60 degree. Okay, pi over 3 means a radian in the unit of radian. Or 60 degree. Because cosine 60 degree or cosine pi over 3 is a half in the first quadrant. And the second solution is in the 4th quadrant, which is a negative. Right, so negative pi over 3 or 11 pi over 3. 11? No, 8 pi over 3. Because 1 pi, because 2 pi, oh, hold on, 2 pi minus 1/3 pi, 5 pi over 3, 5 pi over 3, right? You can use either one. We can, if we measure negatively, we get negative pi over 3. Or if we measure positively, that's 2 pi minus pi over 3. 2 pi is 6 pi over 3. 6 pi over 3 minus pi over 3, which is 5 pi over 3. So we get two solutions, pi over 3 and 5 pi over 3. All right, that's 6. Now let's see, 7. 7 inequalities. We'll solve these inequalities. So we have considered the numerator and denominator. So this sign is important. It's positive. Positive is saying if the numerator is positive, the denominator has to be positive because positive divided by positive is positive. If the numerator is negative, then the denominator has to be negative because negative divided by negative is positive. So we have two cases. So let's split into two cases. So first, x minus 4 is positive, which means x greater than 4. And the second one is x squared minus 64 is positive. But this one we have to, which means x squared, you can think in two ways. You can either factor it into 2, because this is the difference of 2 squares, or you think x squared has to be greater than 64. So how do we think about x squared greater than 64? Draw a line. Because x can be negative or positive, right? This is 0 here. And 64, square root of 64 is 8. So either 8 or negative 8. If x is positive, it's squared to be greater than 64. It has to go from here, right? X has to be greater than 8. If negative x squared be greater than 64, that means x has to be in the negative side, has to be less than. So the solution for this one is from negative infinity, I'm going to use this, negative infinity, up to negative a, union, I'm going to use u, union a up to positive infinity. All right, now we have these three things considered. And of course, those two doesn't have any unit intersection. So looking for the intersection of x greater than 4 and this. So the solution for the first one is x greater than 8, right? Because if x greater than 8, x greater than 4. But if x greater than 4, it won't necessarily mean x greater than 8. So that's the first case. Second case is similar, okay, but both be negative, which means we switch the sign to be x less than 4 and x squared minus 64 less than 0. X minus 4 less than 0 and x squared minus 64 less than 0. So let's just check the solutions. Oops. Sorry, I hope you don't hear the annoying sound, which is from my upstairs. Okay, so then you see this is a combination. So when you do the negative, both be negative, you should get the solution as from negative a to 4. Then union this one from a to positive infinity. Right, that's annoying. Okay, let's go to number 8. So number 8, oh my goodness. I hear the sound. I have to move to another room. Hold on 1 second. So let me stop recording for this. I'm gonna keep going.